Good morning, students and parents. Welcome back to Mathematics 9 discussion via Facebook Live. Before we start our lesson, make sure that you are physically and mentally prepared for our today's topic. You must have your pen and your notebook with you so that you can take down some important notes during discussion. If you are ready, then let us begin. Our today's lesson is about the roots of a quadratic equation, its characteristics, and the relationship to the coefficients of a quadratic equation. At the end of the discussion, you must be able to describe the roots of a quadratic equation using discriminant. Determine the number of real solutions of a quadratic equation. Find the sum and product of the roots of a quadratic equation. And lastly, form a quadratic equation. Let us have a short activity as a recap of the said topic. In this, you are going to choose the reaction response that corresponds to the correct answer. Type your reaction in the comment section below. You have 5 seconds to think and to type your answer. Are you ready? Let's begin. Number 1. Which of the following quadratic equation is written in standard form? Is it A, like, care, or heart? Timer starts now. Time is up. The correct reaction is like. Recall that a standard form for a quadratic equation is written in the form ax squared plus bx plus c is equal to 0. Number 2. In the given quadratic equation below, what is the value of the coefficient b? Choose your react response. Is it A, like, care, or heart? Timer starts now. Time is up. The correct reaction is care. Since the given quadratic equation is in standard form, then we can identify the coefficients of A, B, and C. A is 16, B is negative 8, and C is positive 1. Number 3. What is or are the solution or solutions of the given quadratic equation below? Choose the correct answer and type its corresponding reaction. Timer starts now. Time is up. The correct reaction is heart. No real solution. Solving this equation by applying addition property of equality, it becomes m squared is equal to negative 25. Take the square root of both sides of the equation. It becomes m is equal to the square root of negative 25. And we know that a square root of any negative number yields to imaginary number. Hence, there is no real solution. Next. Which of the following best describe the given number? Square root of negative 4. Choose the reaction that corresponds to your answer. Timer starts now. Time is up. The correct reaction is heart. Like what I mentioned earlier, square root of negative number yields to imaginary number. Last, which of the following best describe the given number 17. Choose the reaction that corresponds to your answer. Timer starts now. Time is up. The correct reaction is like, because 17 can be expressed as a ratio or quotient of two numbers, like 17/1. I hope that you were able to recall some previously discussed topics. This will help you to understand our today's lesson. For the first part of our lesson, nature of roots and number of real solutions of a quadratic equation. How do we determine the nature of roots and number of real solutions of a quadratic equation? From the previous lesson, you are introduced to quadratic formula, and it is given by x is equal to negative b plus minus square root of b squared minus 4ac all over 2a. In this formula, notice the expression inside the radical. B squared minus 4ac is called the discriminant. This will be used to determine the nature of roots and number of real solutions of a quadratic equation. We denote this as d is equal to b squared minus 4ac. But how can we describe the roots of a quadratic equation? This table shows the possible values of d with its corresponding number of real roots and the nature of roots. In the first row, the value of d is equal to 0. There is one real root of multiplicity 2, and that the roots are real, rational, and equal. The one real root of multiplicity 2 means one real number existed as a root twice. This can be seen in a perfect square trinomial. Recall that in a second degree equation, which is the quadratic equation, there will be two roots. So, a perfect square quadratic trinomial will have two roots that are the same number. For the second and third row, d is greater than 0. This means the sign is positive. It can be a whole number, a fraction, a decimal, or a combination of whole number and decimal. The only difference is in the second row, the value is a perfect square, like 4, 9, 16, 25, 36, and so on. While on the third row, it is not a perfect square, like 2, 5, 7, 11, 24, 27, and so on. If the value of d is a positive perfect square, then it has two real roots. And the roots are real, rational, and unequal. If the value of d is a positive non-perfect square, then there are two real roots, and the roots are real, irrational, and unequal. For the last row, the value of d is less than 0. This means that the sign is negative. It can be a negative whole number, fraction, decimal, or combination of whole number and decimal. There are no real roots, and that the roots are non-real or imaginary. This table will serve as a guide to describe the roots of a quadratic equation using the discriminant. So what are the steps to determine the number of real roots and nature of roots of a quadratic equation? You must remember the acronym DISC, which is also the first four letters of the word discriminant. T stands for determine if the quadratic equation is in standard form. Ax squared plus bx plus c is equal to 0. Next is I. Stands for identify the values of A, B, and C. The value of A, B, and C will be coming from the quadratic equation written in standard form. This is the reason why you must always express the quadratic equation in standard form. For S, it stands for solve the value of discriminant using b squared minus 4ac. And lastly, C stands for check. Checking the value or the table for the discriminant value for its corresponding number of real roots and nature of roots. Let us now apply these steps in the following examples. Number 1. Find the number of real roots and nature of roots for 16x squared minus 8x plus 1 is equal to 0. Again, use the acronym DISC as a mnemonic device to easily memorize the steps. First is D. Determine if the given is in standard form. Observe that the given quadratic equation is in standard form. So, we can now proceed to the second step. Identify the value of A, B, and C. From the given quadratic equation in standard form, A is equal to 16. B is equal to negative 8. And C is equal to 1. Third step is S. Solve for the value of discriminant. Using D is equal to b squared minus 4ac, fill in the value of B, A, and C. For B, we have negative 8. For A, we have 16. And for C, we have 1. Then simplify the terms containing grouping symbols. The square of negative 8 is 64. Minus 4 multiplied by 16 multiplied by 1, we will get 64. Further simplifying, 64 minus 64 is equal to 0. Therefore, the value of t is equal to 0. Last step is C. Check the table of values of the discriminant. From this table, let us find the value of d. That is equal to 0. That is in the... Yes, that is in the first row. So going back to our example, the quadratic equation 16x squared minus 8x plus 1 is equal to 0 has one real root of multiplicity 2, and the roots are real, rational, and equal. For the next example, what is the number of real roots and nature of roots for x squared plus 2x plus 3 is equal to 0? Again, the acronym is DISC. First step is to determine if the given is in standard form. By observation, the given is in standard form. Next is to identify the value of A, B, and C. From the given quadratic equation in standard form, A is equal to 1, B is equal to 2, and C is equal to 3. Third step, solve for D. Fill in the value of B, A, and C. For B, we have 2. For A, we have 1. And for C, we have 3. Then simplifying, we have the square of 2 is 4. Minus 4 times 1 times 3 is 12. Simplifying further, 4 minus 12 is equal to negative 8. Therefore, the value of t is negative 8. Last step, checking the table. So we're looking for the value of d that is negative. So that value of d is in the, very good, that's in the fourth row. Going back to our example 2, the answer will be there is no real roots and the roots are non-real or imaginary. For the last example, determine the number of real roots and nature of roots for 2x squared minus 3x is equal to 4. So for our acronym DISC, first step, rewrite the equation to 2x squared minus 3x minus 4 is equal to 0 because the given quadratic equation is not in standard form. So this is now the standard form of the given quadratic equation. Next, identify A, B, and C. For this, the reference is the rewritten quadratic equation, which is 2x squared minus 3x minus 4 is equal to 0. Hence, A is equal to 2. B is equal to negative 3. And C is equal to negative 4. Observe that if you use the given equation as a reference to the value of A, B, and C, the value of C will be positive. And in the standard form, it is negative. Therefore, you must always express the quadratic equation in standard form to get the correct value of A, B, and C. Let us proceed now to third step. Solve for the value of D. Fill in the value of A, B, A, and C. For B, we have negative 3. For A, we have 2. And for C, we have negative 4. So square of negative 3 is 9 minus 4 times 2 times negative 4 is negative 32. The negative of negative 32 gives a positive sign 32. Then break down 9. And 9 plus 32 is equal to 41. Therefore, the value of D is equal to 41. Final step is checking the table. Take note that the value of D is positive. And there are two cases if D is positive. That is when D is a positive perfect square value or positive non-perfect square value. 41 is the computed value of D. And it is not a perfect square. Thus, look for the value of discriminant that is a positive non-perfect square. And that is in the third row. Going back to the example for our final answer, there are two real roots, and the roots are real, irrational, and unequal. I hope that you understand the steps to find the number of real roots and nature of roots of a quadratic equation. In finding solutions of a quadratic equation, it is suggested to check first the value of discriminant to determine if the equation will have or will have no real solutions. For the next part of our lesson is finding the sum and product of the roots of a quadratic equation. How can we find the sum and product of the roots of the quadratic equation? A quadratic equation in standard form, ax squared plus bx plus c is equal to 0, has two roots, r sub 1 and r sub 2. Then, the sum of the roots can be solved using r sub 1 plus r sub 2 is equal to the negative of the fraction b over a. And the product of the roots can be solved using r sub 1 times r sub 2 is equal to c over a. The sum and product of the roots can be used to form a quadratic equation. There are three steps in finding the sum and product of the roots of a quadratic equation. It is given by the acronym DIS. D stands for determine if the quadratic equation is in standard form. I is for identifying A, B, and C. And last step is S. Solve for the sum and product of the roots of the quadratic equation. Let us now apply these steps in the following examples. Find the number or find the sum and product of the roots of x squared minus 3x minus 28 is equal to 0. For the steps, follow DIS. First step, determine if the given is in standard form. By observation, the given equation is in standard form. Next step is to identify A, B, and C. Referring to the given, A is equal to 1, B is equal to negative 3, and C is equal to negative 28. Last step, solve for the sum and product of the roots. Let us begin with sum of the roots. By using the formula r sub 1 plus r sub 2 is equal to negative of the fraction b over a. Fill in the value of b and a. We have b is equal to negative 3 and a is equal to 1. Then divide negative 3 and by 1. The quotient is negative 3. And then simplifying further, negative times negative 3, the product is positive 3. Therefore, the sum of the roots is equal to 3. For the product of the roots, we will use this formula. Fill in the value of C and A. We have C is equal to negative 28 and A is equal to 1. Negative 28 divided by 1 is equal to negative 28. Therefore, the product of the roots is negative 28. Did you get that? Let us try more examples. Second example. Given x squared minus 8x is equal to 9, find the sum and product of the roots. Using the acronym DIS as a guide, start with determining if the equation is in standard form. Notice that the right side of the equation or the given equation is not in standard form. So we have to rewrite this to x squared minus 8x minus 9 is equal to 0. Next is to identify A, B, C. A is equal to 1. B is equal to negative 8, and C is equal to negative 9. Last step, solve for the sum and product of the roots. Starting with sum of the roots, substituting the value of B and A. We have B is equal to negative 8 and A is equal to 1. Next is to identify or divide negative 8 by 1. The quotient is negative 8. And simplify to get the answer. Negative times negative 8 is positive 8. Therefore, the sum of the roots is positive 8. Let us now proceed to solving the product of the roots. Substitute the value of B and A, or C and A rather. C is negative 9 and A is 1. Negative 9 divided by 1 is negative 9. Therefore, the product of the roots is negative 9. And for our last example, solve for the sum and product of the roots given 3x squared plus 4x plus 1 is equal to 0. So, determining if the given is in standard form, yes, the given equation is in standard form. Therefore, we can proceed now to identifying the value of A, B, and C. Thus, A is equal to 3, B is equal to 4, and C is equal to 1. Last step, let us solve for the sum and product of the roots. Beginning with sum of the roots, fill in the value of B and A. For B, we have 4. And for A is 3. Then 4 divided by 3 is 4/3. Then simplifying further, we will get negative 4/3. Therefore, the sum of the roots is negative 4/3. And now for the product of the roots, substitute the value of C and A. C is equal to 1 and A is equal to 3. Then 1 divided by 3 is 1/3. Therefore, the product of the roots is equal to 1/3. I hope that you can find now the sum and product of the roots independently. We can now proceed to the last part of our today's discussion. The last part of the discussion is forming a quadratic equation. How can we form a quadratic equation? There are two methods to form a quadratic equation. First is the reverse factoring, and the second one is the application of sum and product of the roots given by the form x squared minus the quantity r sub 1 plus r sub 2 multiplied by x plus r sub 1 times r sub 2 equals to 0. The reverse factoring can be used if the given are the two solutions. And for the application of the sum and product of the roots, it can be used if two solutions are given. It can also be used if the sum and product of the roots are given. You cannot use the reverse factoring if the given is the sum and product of the roots. Let us try these examples. Number 1. Write a quadratic equation given r sub 1 plus r sub 2 is equal to 11 and r sub 1 times r sub 2 is equal to 24. In this example, we cannot use the reverse factoring method. Instead, we will use the application of sum and product of the roots given by this form. Fill in the value of sum and product of the roots. For the sum of the roots, it is 11. And for the product of the roots, it is 24. Simplifying, we will get x squared minus 11x plus 24 is equal to 0. And that is, or this is, the quadratic equation formed from the given. Next example. Form a quadratic equation given the roots x is equal to negative 4 and x is equal to 7. For this example, we can use any of the two methods. I'm going to show you the two methods of forming the quadratic equation using the given roots. Using the reverse factoring method first. Given x is equal to negative 4, we will express this equation equal to 0. Since we want the right side of this equation to be equal to 0, therefore, we must add positive 4 to both sides of the equation. Then we will come up with x plus 4 is equal to 0. For x is equal to 7, we will do the same, like what we did with x is equal to negative 4. We will add negative 7 to both sides of the equation. This will give us x minus 7 is equal to 0. Then by zero product property, we will write x plus 4 is equal to 0 and x minus 7 is equal to 0 to quantity x plus 4 multiplied by the quantity x minus 7, and they are equal to 0. Multiply x plus 4 and x minus 7 using any method like vertical multiplication, distributive property, or FOIL method. In this example, any method can be applied. So, using distributive property or FOIL method, x times x is x squared. X times negative 7 is negative 7x. 4 times x is positive 4x. And last, 4 times negative 7 is negative 28. Then equal to 0. Notice in the product, the terms negative 7x and 4x, positive 4x, can be added. And the sum is negative 3x. Therefore, the quadratic equation formed is x squared minus 3x minus 28 is equal to 0. And now, using the second method, let us find the sum of the roots by adding. Yes, by adding the two given roots. So we have negative 4 plus 7 is equal to 3. And getting the product of the two given roots, negative 4 times 7 is equal to, yes, that is negative 28. And then we are going to substitute the values of sum and product to this equation. For r sub 1 plus r sub 2 is equal to, what is the value? Yes, that is 3. And for the product of the roots, that is, yes, that is negative 28. You're very good. Simplifying further, we have x squared minus 3x minus 28 is equal to 0. And that is the quadratic equation form. Now look at the comparison of the two methods. It shows that whichever method you are going to use, you will still come up with the same answer as long as the steps are correct. For the last example, using the roots, r sub 1 is equal to 2 plus square root of 3 and r sub 2 is equal to 2 minus square root of 3 for a quadratic equation. In this example, the two roots are given. Therefore, we can use any of the two methods. The application of sum and product of the roots is easier. So, that is the method I'm going to use. For the sum of the roots, get the sum of the two given roots. So we have 2 plus square root of 3 plus 2 minus square root of 3. Notice that the radical term when added is equal to 0. What remains is 2 plus 2. Therefore, the sum of the roots is equal to, yes, 4. For the product of the roots, we have 2 plus square root of 3 multiplied by the quantity 2 minus square root of 3. Observe that the two terms of both binomials are the same, and that the terms in the first binomial is separated by addition, and the terms of the second binomial is separated by subtraction. With this, we will recall the, yes, sum and difference of same two terms, given by this equation. A plus B, or quantity A plus B, times the quantity A minus B is equal to A squared minus B squared. We can apply this formula to find the product of the two roots. So 2 times 2 in this given root can be expressed as, yes, 2 squared minus square root of 3 times square root of 3 can be expressed as, yes, the square of x square root of 3. Simplifying, the square of 2 is, yes, That's equal to 4. Very good. Minus the square of square root of 3 is equal to, what do you think? Great. That is equal to 3. And 4 minus 3 is equal to what? 1. Therefore, the product of the roots is equal to 1. Going back to this quadratic equation for sum of the roots, substitute 4. And for the product of the roots, substitute 1. The quadratic equation now that can be formed, what they think? Okay, so I can see answers in the comment section. And that is equal to x squared minus 4x plus 1 is equal to 0. I hope you learned a lot from our today's discussion. If there are part of the lesson that confused you, feel free to type it in the comment section below. And if there are questions that will not be answered later, you can ask it to your teacher tomorrow during your follow-up discussion. So for our generalization, to determine the number of real roots and nature of roots of a quadratic equation, use the formula b is equal to b squared minus 4ac, and that b squared minus 4ac is called the discriminant. Follow the acronym DISC as steps to find the number of real roots and nature of roots. So these are the steps. And for the table, in checking, we have this. This will give us a description of the nature of roots and number of real solutions. And the steps to find the sum and product of the roots is given by the acronym DIS. And these are the steps. Lastly, the two methods to form a quadratic equation is by reverse factoring method and the application of sum and product of the roots. And now, we will proceed to the question and answer part. Type your question in the comment section below, and our moderators will randomly select the question. So we are still waiting for the question. It seems that the moderator is still waiting for the question. Okay, since there is no question given to me by the moderator, so let me now end this discussion. For your assignment, answer try this both A and B on lesson 2 of your learning packets. Thank you for your active participation and deep listening to our today's discussion. Always remember that, anuman ang sitwasyon, tuloy ang edukasyon. God bless you all.